Tickets from and to airports, use each one starting at JFK. Example, one path is JFK, MUC, LHR, SFO, SJC. In this diagram, a double-ended arrow between two airports means we have two separate tickets, one flight in each direction. For example, between JFK and ATL there is one ticket from JFK to ATL and one from ATL to JFK. We must use each ticket exactly once. Example 2, from JFK we can go to ATL or SFO. We must choose ATL first because it is lexicographically smaller. The full itinerary is JFK, ATL, JFK, SFO, ATL, SFO. Approach, Hierholzer with sorted adjacency. Build the graph, sort each airport's list, then DFS from JFK, when stuck append and reverse for the itinerary. We'll run Hierholzer on this example. The adjacency list is in tabular form, the outgoing lists are in sorted order so we always pick the lexicographically smallest destination. We'll walk from JFK with the stack and visited edges shown below, and build the itinerary from the post order when we backtrack. We start at JFK. We push JFK onto the stack, so the stack already has JFK in it. From JFK we have ATL and SFO. We choose ATL first because it's lexicographically smaller. We follow the edge and push ATL onto the stack. From ATL we have JFK and SFO. We choose JFK. We follow the edge and push JFK onto the stack. From JFK we now only have SFO left. We follow the edge to SFO and push SFO onto the stack. From SFO we have ATL. We follow the edge to ATL and push ATL onto the stack. From ATL we now only have SFO left. We follow the edge to SFO and push SFO onto the stack. We're stuck at SFO, there are no unused edges left. So we backtrack. We pop from the stack one by one and append each popped vertex to the result. That order is called post order. In this example we never find an unused edge during backtracking, we just keep popping until the stack is empty. The list we built is the result, but it's in reverse order. Now we reverse the result to get the final output. How is this different from regular DFS? Regular DFS marks vertices as visited, so we would never revisit a vertex. But here we must use every edge once, so we have to revisit vertices like JFK. Also, regular DFS usually records in discovery order. Here we record in post order when we backtrack, then reverse. So regular DFS would either block revisiting and miss edges, or give the wrong path order. V is the number of distinct airports, E is the number of tickets. Time is O of E log E, we build the graph in O of E, sort each vertex's list, the total length of all lists is E, so sorting is E log E, Hierholzer's algorithm, that's Eulerian DFS, visits each edge once, so O of E. The dominant term is E log E, space is O of V plus E for the graph, and O of V for the Hierholzer stack in the worst case. So O of V plus E. Pseudocode for Reconstruct Itinerary. We build the graph and sort each adjacency list, then run Hierholzer. Stack starts with JFK, and we either push the next destination or pop and append to result. Finally we reverse the result and return it. Sort each vertex's list so we always take the lexicographically smallest next edge. Initialize the stack with JFK and an empty result list. While the stack is not empty, let U be the top of the stack. If U has an unused outgoing edge, take the next destination V from U's list, e.g. pop from ADJ, U. Push V onto the stack. Else we're stuck at U, pop U and append it to the result. Pop U from the stack and append U to the result. Reverse the result list to get the itinerary in the correct order. Return the result as the itinerary.